Evaluating the 6 trigonometric functions using the unit circle. The unit circle is a circle centered at the origin of a coordinate plane with a radius of 1. This circle can be used to solve many trig functions if it is used correctly. First, we can split up the circle into 4 parts, where each section is in a different quadrant on the coordinate plane. The circle begins with the point 1, 0, where the degree of the central angle is 0. Then, at the point 0, 1, the central angle measures 90 degrees, or pi over 2 radians. The next point, negative 1, 0, makes a straight central angle, which means the measure is 180 degrees, or pi radians. Lastly, the point 0, negative 1 has a central angle measure of 270 degrees, or 3 pi over 2 radians. The circle can be further split up, where each section either measures 45 degrees, or pi over 4 radians, represented by the blue lines, or each section measures 30 degrees, or pi over 6 radians, represented by the green and purple lines. If you remember, the opposite side of a 30, 60, 90 triangle, the hypotenuse of 1 equals the square root of 3 over 2, and the adjacent side equals 1/2. If we look at the line that makes a 30-degree angle on the circle, we can see that it makes a right triangle with the x-axis. We can apply the rules for a 30, 60, 90 triangle and know that the adjacent side, or x value, equals 1/2, and the opposite side, or y value, equals the square root of 3 over 2. The same thing happens for any line on the unit circle. Eventually, if we use what we know about circles in the coordinate plane, our unit circle ends up looking something like this. The values for each opposite line is the same. The only thing that changes is the sign as we change quadrants. We can now use our unit circle to determine the 6 trigonometric functions. Let's say we are given the problem sine of pi over 3. First, we must find the angle pi over 3 on the unit circle. We know that sine is the opposite over hypotenuse, and the opposite side is equal to the square root of 3 over 2. Anything divided by 1 is equal to itself, so the sine of pi over 3 is equal to the square root of 3 divided by 2. Cosine of pi over 3 is equal to the x value, 1/2, for the same reason. The adjacent side is 1/2, and that divided by 1 is equal to 1/2. Tangent is the opposite side over the adjacent side, which means we must divide the square root of 3 divided by 2 by 1/2, or multiply by the reciprocal 2 over 1, which gives you the square root of 3 as your answer. We know that secant, cosecant, and cotangent are the reciprocal functions. So cosecant of pi over 3 is equal to the hypotenuse, 1, divided by the square root of 3 over 2, or the opposite. Simplified, the answer is the square root of 3 over 2, but you can't have a square root in the denominator, which means you need to rationalize. Multiply both the top and the bottom by the square root of 3, and you are left with 2 square roots of 3 divided by 3 as your answer. Secant of pi over 3 is 1, the hypotenuse, divided by 1/2. This is the same thing as multiplying by the reciprocal 2, so your final answer is 2. Finally, cotangent is adjacent over opposite. For the angle pi over 3, the adjacent side is 1/2, and the opposite side is the square root of 3 over 2. Multiply 1/2 by the reciprocal, and you are left with 1 over the square root of 3. Rationalize the denominator by multiplying both sides by the square root of 3, and the final answer is the square root of 3 over 3.
Created using Powtoon.